We're now going to show you how box plots give you a great visual summary of one data set or multiple data sets. So let's do this with a really interesting example. It's actually a life and death example that's used by a lot of statisticians to explain box plots. We'll talk about the 1970 Selective Service Draft Lottery in the US. This was, if you don't know your history, the peak of the Vietnam War. So they put every birthday, January 1st through December 31st, including February 29th, there was a capsule with each date put in a big container, and they mixed them up. They thought they mixed them up randomly. They put in December last, remember that, January 1st, then February dates, etc. Then they would pick the balls out, and basically January 1st was the 305th capsule picked out, January 2nd, the 159th. And if you got a low number, like number 17 there, you were pretty likely to be drafted and sent to Vietnam. So obviously this was a life and death decision. If you got a number of 350, then basically you had no chance of really being drafted. You could have enlisted, of course. Okay, so statisticians looked at this draft lottery and they said it really wasn't done randomly or fairly, and the box plots will help us really figure that out. Okay, so I'm going to show you the finished box plot first to try and explain what the parts of a box plot mean, and then we'll create this and come back and interpret it. So basically for every month, okay, those were our 12 populations, the draft lottery numbers for the month. So January, there were 31 days in January, so these were the numbers for the dates in January, the order in which they were picked out. So for instance, that date in January was picked out very late, that date in January was picked out very early. So how could you summarize these 366 days of draft lottery numbers very quickly? Well, this is what we mean by actually a box plot or a box and whisker plot. You'll hear the whiskers are the lines, the boxes are the boxes. Okay, so what are the pieces of information you get in a box plot about a data set? Okay, well you have the box. Okay, the box, the lower limit of the box is the 25th percentile of the data. Okay, the upper limit of the box is the 75th percentile of the data. And then you see inside the box, you'll see an X and you'll see a line. Okay, the horizontal line is the median. Okay, and the X is the mean. Okay, so we've been talking about those things, but now we can actually see them, as the Chinese say, a picture's worth 1,000 words. Then you have the whisker. Okay, top whisker and the bottom whisker. Okay, and now the top whisker basically is computed by Microsoft to be the 75th percentile plus 1.5 times the interquartile range. What's the interquartile range? It's the 75th percentile minus the 25th percentile. Or you cut it off at the top value of the data set. And basically, outliers, anything that's more than 1.5 interquartile ranges from either end of the box. We'll see some outliers later. Okay, but this gives us a really quick summary of the data sets. We can talk about skewness, we can talk about typical value, we can talk about spread about the mean and compare data sets. So in the next video, we're going to create the box plot for the draft data, and then we're going to see that statisticians were really right, that basically this was not a fair lottery. Remember we said the December dates were put in last, so if you think about last in, first out, if you didn't sort of mix those capsules up randomly, you'd expect the later months of the year to be picked earlier, and that's what happened, and the box plot makes that clear.